Okay. So some of you have already done, data analytics, taken data analytics elective. So I can start with a very simple question. Can you tell me what is the difference between analysis and analytics? Yes. How do you differentiate between analysis and analytics? So there is one topic called predictive. Okay, now you have like predictive analysis as well and predictive analytics as well. So what does predictive do? It basically has three steps. You have to pass data, you analyze the past data and create a model using the past data. That's the second step. And use that model to predict for the future. Okay, that's the third step. So these three steps are necessary for any predictive technique. Okay, so you can do predictive analysis, you can do predictive analytics. So what is the difference between analysis and analytics? Can anybody tell me? Especially I'm talking in terms of predictive. Okay, it could be otherwise different, but especially in terms of predictive analysis and predictive analytics. How would you differentiate? Anyone? Yes. So the problem is if you don't answer me, I'll have to call names. Do you want me to do that? Should I say that nobody here has knows the difference between analysis and analytics? Tell me, what do you do in analysis? In any data analysis, what are the typical steps you follow? Those who have taken, you have studied NIME, isn't it? What are the steps which are followed in NIME? Yes.
Data gathering, then data cleaning,
Hmm.
then applying algorithm to data, and then be doing analysis.
Okay. So, can anybody tell me the difference between analysis and analytics?
Ma'am, in analysis, we usually what we do is we extract the useful information, and then using that information, we forecast, identify patterns, and then we identify errors in that data. This is all comes under analysis, and in analytics, we transform data into insights.
Okay. Not exactly. Okay,
May
but
I try?
yeah, please.
So as per my understanding, analysis will be like collecting the data, sorting it out, and trying to collect and gather, sort the data as per our need. While analytics would be a part of analysis and would include making something out of the data that we've gathered during the analysis process.
Uh, Actually, let me tell you what. Okay, so you have something called visualization, okay, or visual analytics, or you also have something called EDA, that is exploratory data analysis. Now, both are used, especially EDA is used before you do the model. Okay, so you say you never make a model without understanding data, because unless you actually get a feel of data, you cannot really treat the data accordingly. Okay, so the first step of anything, like whether you want to do a basic analysis or you want to do PhD level analysis or any big or small project, the first thing you do is you explore the data. Okay, so data exploration. So that data exploration uh, is uh, basically either you call it as a visual analytics or you can call it as a ED, exploratory data analysis. Okay, same thing, similar things, but that exploration of the data you do for two reasons. Okay, either you do it for doing before building the model or getting some insights for the current data. Okay, so if you are gathering insights for the current data, okay, if you want to do understand, you're actually studying the current data and want to gather insights and take decisions on the current data, then what we do is basically called dashboarding. Have you heard about dashboards? So dashboarding concept is specially for the current data. That's the basic difference between dashboarding and other type of data analysis. Dashboarding is a very special case. Otherwise, historically, otherwise by default, we use historical data. Okay, for model building, do you agree that we do not generally use current data? You use the historical data for any model building. But when you do dashboard, you need a current data. Okay, so if you do analysis, if you want to understand insights, before doing the dashboard, you have to again study the data. So you first study the data before doing dashboard. You'll also study the data before doing any model building. The only difference is if you are studying before model building, it has to be historical data. And if you are studying before dashboarding, it generally is a current data. Okay, so you'll generally use current data and create a dashboard. You'll make sure that the data refreshes so that every time the data refreshes, you get the new data, current data populated, and then you get a latest dashboard. And then whoever uses the dashboard uses that dashboard and takes decisions. That is basically a visual analytics part. But when I'm talking about predictive analysis, still you will do some kind of exploration to understand the data, to make sure the data is treated well. Okay, so data exploration is a completely different concept, which is not talking about predictive. So when I do predictive, in predictive, I can do predictive analysis or predictive analytics. Okay, so how do I differentiate between predictive analysis and predictive analytics? Remember, when you say predictive, you have all three steps, whether I do analysis or analytics. So you have the past data, you analyze it, you create model using past data, and you use the model for the future. Okay, and of course get insights from. So whether you do analysis or analytics, you still want the insights. Okay, so it's not, the difference is not on the insights. Any other difference can you think of? So majority, in fact, many people use this terminology as interchangeable. Okay, they just use any of the terminology, whether analysis or analytics, but there is a slight difference between the two. Anybody can figure out a difference? Okay. So do you agree that when you use the past data, why do you use the past data? Because you want to learn from the past and use it for the future. Do you agree?
Yes, ma'am.
Okay. So you will not stop at the past. And though you study past extensively, you don't want to conclude for the past. You want to conclude for the future. You want to learn from the future. And that is why you study the past. Okay. So when you use data analysis, what you use is you study the past data, create the models, and use that model to conclude about the future. Now, any model is good as far as it is accurate. Okay, so whether I do analysis or whether I do analytics, do you agree that I need a model which is as accurate as possible? Because only if the model is accurate, then I can take the conclusions from the model and use it in the business and make profit out of it. If my model itself is wrong, I will have serious issues. So how can you tell me, how do I assess whether the model is correct or wrong?
Ma'am, maybe we can test the model using sample data. Because
Okay.
if we have both the input and output, we can just cross verify whether we are getting the correct output or not.
Absolutely. Okay. So that exactly what that is a difference between analysis and analytics. Okay. So both need accuracy, both need correct model for the future or correct results for the future. But the approach for analytics and analysis is different. Okay. So when you use data analysis, you use statistical methods to avoid something called overfitting. Have you heard about overfitting? Can you tell me what is overfitting? Yes,
When you try to
Pranav.
match oh, so sorry. So
Yeah, you can say try to match.
yeah, when you actually are matching all your data points on, like, when you're fitting your training data set completely. So let's say if your data points are very complex or very on an arbitrary plane, you're actually matching exact the flow, right? So you are trying to mimic it and not you're not inferring any insights from them. You're just trying to overfit the model itself.
Okay. Yeah, you are right there. Any other answer, Pranav?
Ma'am, when your model works well on your training data, very well on your training data, but does not work well on your test data.
Absolutely. Okay, so that's an objective difference, objective way of defining overfitting. Okay, so you have created a model. First of all, you have created two different data sets: training set, testing set. Okay, your training set is the one you use to create a model, and test set you have kept separate. You have not used the test set at all in the model, but that objective of that test set is just to test the model. Okay, so you create a model, and your model is very excellent. It works very accurately on the training set, that means on the data with which it is created. But the moment you try to put it on a new data in that, or a test data in that, it fails pathetic. Okay, so that's basically is overfitting. When your results are very good on the train set, or very good on the data with which you have created the model, but the moment you put a different data or a new data, your model fails pathetically. Or the data, the if you put a data where the model has not seen the data before, and you use that data, the model works very bad. That's basically the overfitting. And this is achieved in analytics. So when you say analytical projects, when you say predictive analytics, this forms the basic building blocks of predictive analytics, where you divide the data into train set, test set. In fact, if you use SAS, you would also have something called validation set. Okay, but we're not discussing that in this. So generally, SAS divides the data into three different sets. You have train set, validation set, and test set. Okay, but we presently we will stick to train set and test set itself. Okay, so when you have distinction, very clear cut distinction, this is your training data, this is your testing data. You cannot use test data to create the model. You will use only train set data. Then the entire approach is different. Okay, because you have divided the data into train set, test set, then I don't care what is done on the model. Whatever you do, make sure that the model works fine on the new data. And that's exactly approach which is followed in analytics. Are you getting this? The approach is create a model which will work fine on the new data. And this is achieved by creating a separation called training set and testing set. Create model using training set, test it on the testing set. And that's exactly what is analytics. In analysis, when we do predictive analysis, we do it little differently. Okay, we do not distinguish, we do not bifurcate our data into train set and test set. Okay, you have just single data. Now tell me, if I have no distinction between training set and testing set, and if I have a single data, how do I assure accuracy, and how do I avoid overfitting? Is there any way I can avoid overfitting? Yes. Yes. Okay. Cross validation, I get this answer always, is yes, absolutely right. Cross validation is a way by which you can avoid overfitting. But you know what cross validation does? It actually creates within the training set, train set and train set, test set concept. So part of train set you consider as test set, and create multiple train test set combinations, and use that to pick up the best parameters, okay, or pick up the best model, whatever you can actually call that. That is, yes, the answer is right. But unfortunately, again, that particular method is for analytics type. Okay, so when you are doing analytics, you would actually do, because again, internally you are dividing the groups as test set and train set. Okay, and generally this is very much extensively done for trees. Of course, you can do it for other techniques as well, but for trees it is more useful. So you do have a cross validation in trees, but as I said, you can use it for other techniques as well. Okay, but again, it is extension of training set and test set extension. Instead of creating a separate test, what you do within a train set, you create bifurcations and use that for the future. Of course, we are going to discuss this in detail when we'll do the trees. Okay, cross validation we are going to discuss in detail. Other than cross validation, is there any way, I'm asking you because you've already done this in the first year, is there any way by which I can avoid overfitting without creating a test set? Yes. Okay, Vibhav is saying reducing features. Can you tell me how do you reduce features? Yes, answer is right. Yes, you reduce features, but how do you reduce features? Yes, everybody.
Ma'am, if we find that a particular data set has maybe 10 columns and one or two of the columns are saturated with a single type of data, so
Hmm.
maybe we can remove those columns in order to avoid overfitting.
Okay, so we generally call in analytics concept. This is there are two things we check basically: relevance and redundance. Okay, so you're talking about relevance. Okay, the two variables are not relevant, suppose. Okay, like for example, if I'm studying India's GDP and one of the variable is Greece GDP, so it's not relevant for my study, so I would just remove it, isn't it? So that's one way of looking at it. But that is again not, yes, that will help you avoid overfitting. Okay, that will help you avoid overfitting. I agree with you. But in general, can you tell me a topic, which a huge topic which you have done in term one, which is to avoid overfitting? Let me just tell you. What, have you studied testing of hypothesis? Yes. Have you studied testing of hypothesis?
Yes, ma'am.
Yes, ma'am.
So tell me, what is the rationale or logic of testing of hypothesis? Why do you need to do testing? What is the rationale you test? Why do you try to find a significant difference or significance? What do you mean by significant? Now, somebody said feature selection. How do you do feature selection? On the basis of significance, not only basis of correlation. It is basically on the basis of significance. So why do I want to find out significance? What exactly significance does? Yes. Anybody? So whenever you do testing of hypothesis, okay, your major aim is to find out significant difference. Okay, so to take a very simple two sample test, okay, you have a test called mu1 equal to mu2. You have two populations, and I have taken sample from one and sample from another. And the mean of one is, let's say, 100, another mean is 110. And I want to see whether there is significant difference between the two populations or not. Is this clear?
Yes, ma'am.
Okay. So when I test a hypothesis, and if the hypothesis is rejected, that means, yes, there is significant difference between the means of the two populations. Okay. So in short, the testing of hypothesis allows me to generalize. Okay. So the basic concept of testing is that whenever you study something and want to conclude beyond what you have studied, you have to test the hypothesis. If you study a particular data and only want to conclude for that data, there is no need to test. Okay. So suppose I have two data sets. Just now I said you have mean of one is 100 and another is 110. Now, do you agree that 100 is different than 110?
Yes.
Okay. So, and suppose this data is for, two different populations. Okay. Like say two different cities, okay, on some parameter, 100 and 110. And if I have studied the entire people of this city and entire people of another city, and I have found out that, okay, one city is 100 and another city is 110, do I have to test the hypothesis to see that they are different? I can see that 100 is different than 110, and I have studied everything. But if I have not studied every population, I have only studied a sample, then it is not necessary that if 100 is one city and 110 is another city, that every time it will have the, do you agree that despite of that, the hypothesis could be rejected that they are equal? Or it is also possible that it is accepted that they are equal? Is it not possible that if you, one city has 100 and another city has 110 and still they are not significantly different? Is it possible?
Yes, ma'am, depending on what level of significance you want.
Not only that, it also depends on the standard error. Okay, if you see in the testing of hypothesis, your standard error plays a very important role. The higher the standard level, the lesser is the significance. Or the lower the standard error, higher is the significance. Okay, remember that always. Okay, and significance tells you generalization. So if I study something and I conclude for only what I have studied, I do not need to test hypothesis. I do not need to generalize because I know exactly what it is and I can directly do the conclusion. But the moment I want to study and conclude beyond what I have studied, there is necessity of generalization, and that is exactly what is achieved by testing of hypothesis. Okay, so testing of hypothesis is a generalization technique. And what do you mean by generalization? Tell me. When you generalize, what exactly you're trying to do? You're saying that, okay, this is not only true for this data, but it is also true for new data. Do you get it?
Yes, ma'am.
Okay, so if you generalize, then you can automatically avoid overfitting. If you can generalize, you can avoid overfitting because that is exactly what a generalization means. Whatever what you're doing is not only true for this data, but it is beyond that data. That means if you consider new data, it will also work true for the new data. That means, okay, I don't really need to worry about which data, whether if I put new data, will it give me wrong results? No, because I have done the generalization. And that is why testing of hypothesis is a very important aspect when you do model building. Okay, so in data analysis, when you do predictive analysis, the majority of emphasis, because we do not have a separate set, we have no option or no choice than to rely on statistics for generalization or to avoid overfitting. Because as I said, every time you do a predictive technique, you want to have a accurate results. Okay, the accuracy is only on the basis of the generalization or avoiding overfitting, because you don't want the inaccurate results. So if you are using analytics, you create two different sets, test set, trend set, and avoid overfitting. If you are using analysis, because you're not setting up a different set for analysis, what you do is you use statistical methods to make sure that you do not have inaccuracy, okay, or you do not do the overfitting. Is this part clear? So analysis majority depends on statistics, and unless you use those statistical techniques, that's why the statistics becomes very important. You have to make sure everything in the statistics is right. Although the model is statistically significant, all the variables are statistically significant. Why? Because that is the way which you can avoid overfitting and avoid incorrect results in the future. Okay, but if you do analytics, then you do not rely on statistics so much, though you do rely actually, because every time you can do different models and test the test set, you will have to use something like stepwise regression, which uses statistical significance to pick up the features. And then of course you can do different permutation combination. Optimization can happen with the test set data, but the basic statistics is still used in analytics as well. But your major inference reliance is on the test set. Okay, so any model which gives you best test set accuracy is supposed to be the best model. Okay, that's exactly the difference between analytics and analytics. Is this clear? Any questions here? So in analytics, statistics takes a little bit backstage. Okay, in analysis, statistics is the king. Okay, you just do everything on the statistical significance, statistical methods, statistical assumptions, everything you do for statistics. Why? Because we do not have any other way by which to understand whether this model is going to work well for the new data as well. So only statistics is to be used. I mean, the only what you have statistics is your resort. You can only rely on the statistics because you don't have a separate set. Okay. Is this clear? And because of that, if you can see the analysis process and analytics process, there's only one difference here is the evaluation phase. Okay, so because in analytics, you do have an evaluation phase because you have a 10 set and test set. Okay, so you generally evaluate your models on the basis of two things. One is test set and another is accuracy metric. What do you mean by accuracy metrics? For example, if you're doing a regression analysis, tell me what will determine the accuracy. How do you measure the accuracy for regression? Yes.
Sum of square errors.
Okay, sum of square errors, or you can say RSME, basically root mean square error, or you can also use something called MAPE, mean absolute percent error. In fact, MAPE is more popular in the industry. Okay, especially in forecasting, MAPE is the most popular technique. We will study MAPE in you have something called autoregressive or ARIMA-SARIMA models, etc. Seasonal autoregressive models. So, of course, for forecasting, MAPE is the most useful technique. So, generally, how do you calculate error? By the way, error is nothing but difference between actual and predict. Okay, so you find out that error, and if you take the average and take a root of it, squared root of first square it, add all of them, take a average of it and take a root of it. That is basically mean absolute percent. Root means square error, RSM. Okay. MAPE is basically different. You divide it by actual as well, so that what you get is in a percentage form. Okay, that's why it's more applied in the industry, because you get a percentage form. Okay, because it becomes unitless, then you can very easily compare it with the different models irrespective of the locations and other things. But anyway, so that is very simple for regression. You also have classification type of models. Can you tell me when do you use classification models? Yes.
For binary data, like yeses or nos or something like that.
Okay, so you can actually have two. Okay, so let me just do one thing. You can go through this. We will do that little later. What I want to know is you have different types of data. You are aware about the types of data. You have qualitative data and quantitative data. So you can say that qualitative data is always discrete. Quantitative data could be discrete or continuous. Okay, so this is a type of data. Now tell me, whenever you want to do any analysis, okay, there are two things which you have to keep in mind to understand which analysis you will do for what situation. Can you tell me what are those two things? Can anybody guess? Yes. Yes. Anybody? One is to slide is in front of you. Can you do anything because you want to do it, or you are restricted by the type of data? So certain data types only allow you to do certain type of analysis. Okay, it's very important. Basically, data type is a very important aspect. But before data type, there is something else which is the most important thing. Can you tell me? Yes. Other than data type, what should I consider for doing analysis?
Sample size.
Okay, let me just make it revise my question. What I'm trying to say is, I have a data. Now I have to decide what should I do on it. Okay, whether should I do regression, logistic regression, or whether should I do cluster analysis, factor analysis, and so on. There are different techniques available. So what technique I will use on the data depends on two important things. One, as I said, is data type, of course. Okay, so if suppose if your dependent variable is qualitative, you cannot do regression even if you want to. Then you will have to do either logistic regression or classification techniques, okay, which is indirectly called as classification techniques. There are multiple classification techniques available, but yes, you will have to do classification techniques if your dependent variable is qualitative. Example is identifying whether a particular transaction is fraud or not, or identify whether a particular person will buy a particular product or not. Okay, so these are basically binary. You want to classify yes or no on the basis of certain things like past patterns of maybe the credit card, or past patterns of the buying of behavior of the person. You want to predict whether the particular person is going to buy or not. Okay, or whether a particular transaction is a fraud or not. So this is typically a classification problem where your dependent variable is qualitative, okay, or discrete especially. Even the digit recognition is another example. Okay, you have a picture and you want to identify whether the digit is 0 or not, 1 or not, and so on. Okay, what is the type of digit? So again, it's a classification problem. Even image classification is another example, and so on. So data type does matter. If your data, if your dependent variable especially is a quantitative or continuous, then you can use regression type methods. And if it is discrete, then you'll have to use classification type method. You don't have any choice there. Okay. The other important aspect is objective. What you want to do. Okay. So objective is very, very important because in fact, the first step is objective. In fact, you'll collect the data according to your objectives. So if you want to do, suppose if you want to do understand the future trends from a data, I may not really do predictive modeling. I could just do pattern recognition like cluster analysis technique. Okay. So depending on what is the objective and what is the data type, you will decide what kind of analysis to be done for what type of data. Okay. So these two things are most important aspects when you decide type of analysis to be done. Is this clear? But type of data also makes a lot of difference. That is where exactly I would come to the next point. Now, there are basically two types of techniques we have. Okay, have you heard about supervised learning and unsupervised learning? Statistically, yeah. Can you tell me the difference between supervised and unsupervised learning?
So, ma'am, for supervised, you do have a data set, and like you have a past data set that you train upon for future this thing. Whereas for unsupervised learning, you are not actually like you're relying on the patterns that the algorithm will find on itself rather than feeding on some external, like a preset model or something like that.
Yes. Okay. So in short, we say in a machine learning language that labeled and unlabeled data. Okay. For supervised learning, you have a labeled data, and for unsupervised learning, you don't have labels, data labels. Okay. So statistically, there are two techniques actually. So this is you can say analytics lingo, but when I say statistics, traditionally we have two types of methods: dependence techniques and interdependence techniques. Okay, which actually are dependence techniques is nothing but supervised learning. Interdependence is unsupervised learning. Okay, so what is dependence technique? As the name suggests, when you use any statistical, any dependence technique or any supervised learning, you classify variables into independent and dependent variables. Okay, so you say, let me take an example of sales and advertising expenses. So when I say that, okay, if I want to do a predictive model, do you agree that I'll say that, okay, which is my independent variable here? Yes. Between sales and advertising expenses, what is going to be the independent variable?
Advertising data.
Yeah, advertising expenses is going to be your independent variable, and sales is going to be the dependent. So basically we talk about cause effect relationship. Whenever you do predictive modeling, it is basically cause effect relationship. You have a cause and you have an effect of the cause. So cause is the independent variable and effect is the dependent variable. Okay, so am I not classifying that, okay, this is my independent variable and this is the dependent variable? Do you agree? So then it is a supervised learning or dependence technique. Okay, so whenever you classify that, okay, this is your independent variable, this is a dependent variable, it has to be a supervised learning technique or interdependence technique. Against that, you also have interdependence technique. Okay, where you do not classify variables into independent or dependent. There is no concept of independent dependent variables there. You just have the variables and you just do some pattern recognition, some grouping, something on the data. So there are two very popular unsupervised learning techniques. One is the factor analysis and another is the cluster analysis. Okay, now both are used for different techniques. Anybody knows? Anybody has heard about factor analysis? Yes. Okay, so we're going to study all this in detail. Actually, this is just an introductory lecture. Let me just give you some basic understanding. But if I tell in one line, factor analysis is nothing but it's a grouping of the observations, grouping of the variables on the basis of their correlation is called as factor analysis. And grouping of the observations on the basis of their distances is called as cluster analysis. Both are grouping techniques. Okay. Factor analysis is called as variable reduction technique and cluster analysis is called as data reduction technique. So to give a simple example, suppose if you have, let's say, 500 observations and 10 variables. So if I group those 10 variables and reduce them from 10 to 2 on the basis of correlations, highly correlated in the same group, uncorrelated in the different group, then what I'm doing is a factor analysis. But those 500 observations, if I group them and let's say if I convert, groups in such a way that similar or, similar people, because suppose each observation represents one person. So similar people are in one group and different people are in the different group, then it is cluster analysis. Okay, and that is generally done on the basis of the distances. So if you have 10 variables, then on the 10 variables, you have 10 dimensional matrix. Okay, imagine 10 dimensional space, and on that 10 dimensional space, those observations which are close will be in the same cluster group, away will be in a different cluster. Okay, so that's exactly the cluster analysis is done. But in short, grouping of the observations on the basis of their distances is cluster analysis, and grouping of the variables on the basis of their correlations is the factor analysis. Okay, so do you agree that when I did this factor, when you do the factor analysis or cluster analysis, do you have any dependent variable there? You just have the variables and you group them. And on that grouping of the variables, you understand some patterns and you get some information or insights from the patterns. Okay, so there is no concept of dependent variables in cluster analysis or factor analysis, which also means that, remember, any predictive modeling technique requires dependence technique. Basically is a dependent technique or a supervised learning technique. Okay, unsupervised learning, you cannot do prediction. You're not supposed to really do prediction using only unsupervised learning method. So using cluster or factor, you are not really supposed to predict for the future. Okay, remember that, because for prediction, you need cause effect relationship, and using that cause effect relationship, you will do a model which you will use for the future. Is this clear? Is it clear? Am I clear here? Okay.
Yes,
So if you have dependent variable and independent variable classification, then it's a dependence technique or supervised learning. If you don't have a dependent variable, you just have a set of variables, you can call them anything, and you do something on that grouping techniques. They are basically interdependence technique or unsupervised learning. Is this clear?
Yes, ma'am.
Okay, so let me test it. Do you know association? What is association? finding the relationship between two variables. That is association. Okay. How do you measure association? Yes.
By correlation.
Absolutely. Okay. Pearson's correlation coefficient, we are assuming both variables are quantitative. Then you can use Pearson's correlation coefficient to measure the association. Okay. Now tell me, this association, is it what you call supervised learning or unsupervised learning?
Unsupervised.
You said unsupervised, isn't it?
Yes.
Absolutely. Okay. Tell me why it is unsupervised.
It's a correlation. There's no cause and effect, right? It's a correlation.
Yes. And do you classify anything into
No.
independent, dependent variable while calculating correlation? You don't need a classification. You just have two variables and you want to find out the interrelationship. Okay. So that's absolutely bang on. Okay. That was basically the test, and it is at least few of you are fully clear that if you classify variables into dependent and independent variable, then only it has to be supervised learning. Otherwise, it is unsupervised learning. Okay, so association is also unsupervised learning. In fact, there is one entire technique. Have you heard about market basket analysis?
Yes.
That uses exactly association, which is completely unsupervised learning technique. Do you get it?
Yes, ma'am.
Yes, ma'am.
Okay, so is the distinction clear? Difference between supervised and unsupervised learning? So the next, what we want to, I know the time is up. I'm so sorry for this. Anyway, I think I have done very similar in the other class as well. Okay, so we will start with this actually. So remember, this is for predictive techniques. Okay, this is only for predictive, because tell me why it is for predictive technique or supervised learning. Because when I'm saying independent variable and dependent variable, we're only talking about predictive techniques. Okay, because only in the predictive techniques you have the concept of independent variable and dependent variable. In unsupervised learning, you don't have that concept. Okay, you just have set of variables and then you don't classify them into categories of independent and dependent variable and so on. Okay, so depending on what type of variable, for example, if your dependent variable is qualitative, it is a classification. And if your dependent variable is quantitative, it is a regression type. Okay, so you could actually use regression for quantitative dependent variables and classification for qualitative dependent variables. Anyway, we will continue this in detail in the next class. Try to get your SPSS on, okay, so that